Hi everyone, and welcome to the last session in the aquatic chamber training. Today, or in this session, we're going to talk about the hardware and software of the aquatic chamber. We're going to start with some chamber installation of the pH probe, some cleaning of or service of the chamber, and then we'll end with software demo, just showing the new features that were included with the aquatic chamber. So first, installing the 6818. Here's the video. So when you receive your 6818, you're going to have your console and your sensor head already, and your fluorometer. If you already have the bottom of the chamber attached, you're going to disattach it there's 2 screws that hold the latches in place right there, and then you have 3 screws holding the manifold in place. So take those away. And the next thing is you're going to put the chamber on its side, and we do this because we want to keep the sample in the chamber at this orientation. And then we're going to attach it securely, and then we're ready to install the chamber. So we're going to first attach this manifold here using those 3 screws we just removed. And you can see here too, we removed the top aperture that was sitting on the fluorometer. So it's just 3 Phillips screws here we used to attach the chamber. There are 2 slightly longer screws and they go on the outside, so then there's a shorter one in the middle. Once we're done with this, we're going to pop the chamber into the aperture. And just to make sure you align this side, because we're going to secure it with 2 screws right here into the fluorometer. And again, these are also Phillips screws. Now we're going to connect the thermistor chamber, or the thermistor cable, into one of the thermocouple ports. And then here we have the light sensor. So the light sensor can be used for estimating transmittance through the chamber. You can also use it when you want to darken the chamber. Let's say you're doing a FE or FM measurement, and then that one will just connect to the regular part in port. And then we're going to connect the D sub, or the DB25 that goes from the aquatic chamber into the auxiliary input. And that's what carries the pump signal and some other things. And then we're going to detach the hose from the base of the sensor head, and then we're going to connect it to the cables coming out, or the tubes coming out from the aquatic chamber. Just so we're rerouting that flow through the equilibrator. The next thing we're going to do is, prior to making our measurements, is installing the pH probe. So the pH probe port is located down here on the side of the chamber. And we can connect the pH probe using the BNC connector up here. So on the instrument through this DB25, we will get the signal, the voltage from this pH sensor. So we disconnect this part down here, and then we pull out the plug. And then we want to make sure we orient the pH sensor. We don't want to tilt it up too much, because then the bubble inside it might come up and sort of ruin the measurements. So just be careful here. And then we're going to push it in slightly. Yeah, we might have to twist a little bit. And then you want to make sure you get all this whole kind of like glass piece through. And then you want to tightly secure it so you don't have any leakage through your chamber. Once the pH probe is installed, you're ready to load and then finally unload your sample after you're done with measurements. So we're going to show how that is done as well. So when we load our sample, we first want to make sure that our pump is on. And this is just to make sure that no backflow of liquid happens here, so we don't get any liquid coming down through here. And we also want to make sure that our pH probe, if we had a pH probe installed, that this port is securely attached, or if we don't, that the plug is securely attached. And then when we load the sample, we want to make sure we go all the way into this chamber. You can see how the bubbles from the pump is making sure that liquid is pushed upwards. And then once we're loaded our sample, then we're going to put in the plug again. Once you're done with your measurements, you're going to do that same procedure but reverse. You're going to stick that the syringe and the needle all the way down into your chamber, and try and hold it on the side. Here I kind of went down into the bubble, so that's why it's taking me a little bit of time to get the sample out, because I'm sucking in some air as well. Just go all the way down and then take it out. So once you're done with this, you probably want to clean your chamber. So you can here we're just using some DI water to rinse the sides. So up here in the headspace, sometimes you might see a little bit of algae gets carried with some of the bubbles. And then once you're done rinsing it, you can take it out again with the syringe and the needle. And repeat that about 3 times or something, just to make sure that your chamber is thoroughly clean. And then once that is done, you can just leave the chamber sitting with the cap off. So you may sometimes need to do a little bit of servicing of the chamber. If solution of suspension has been sitting in there for a little bit, you might want to clean it out. So here we're just going to show how to take some of those filters off and access the inside. So this here is the equilibrator. So reference air goes in here and then it gets humidified by that sample airstream up in the headspace. So there's 4 screws that hold this equilibrator in place. And again, Phillips screws. During this, unscrewing this here, we can see this little thing right here on the side, and that's the septa that Jason was talking about earlier, where we can stick in an optode, for example, if you want to make those type of measurements. So now we've taken the equilibrator off. We see there's a PTFE filter located right here. And these might need to be replaced from time to time. And then in here, we can also clean this out if you have some algae sitting there. Now we're flip the chamber upside down. So this is underneath the cuvette. So this is where those little perforations where the bubbles go through. Another thing you can see on this one is these 2 threaded holes here. So if you have a water bath and you want to hook that up, you can hook it up here, and then you can have water go through the chamber or outside the chamber to control it at a certain set point. Okay, in this, we have a little filter. And this filter might need to be replaced from time to time too, as algae or things may get down there. The little perforation, the plate with perforations, can be popped out and cleaned as well. And we have a thin metal stick here that can be used to just clean those holes out. It's just showing how it gets out on the other side. So yeah, that was a little bit about the cleaning and servicing the chamber, how to install it, etc. And more instructions are in the manual. Now we're going to go over to talking about the software, showing some of those new features. So I'm going to stop sharing here for a second and then share my screen and my 6800. So we're just going to go through kind of menu screen by menu screen, just to talk about the new features. So with when the new software comes out for the 6800-18, it's going to have this aquatic chamber selection as for an aperture. So you're going to see here the ID is still going to be 6800-01A. This revision here, 1Q, is going to go away. It's just going to become 0. Configuration will look the same. Connections down here will look the same. So most of these will be the same as using the 6800 for leaf level measurements. As of current, there are no specific warm-up system tests for the aquatic chamber. And they might come after hand as we notice, certain things that might need to be tested specifically for the aquatic chamber. But right now, most of it is functioning just like if you had a leaf chamber connected. Going down to the calibration screen, there's one added, besides the regular ones, there's one new calibration, and that is the aquatic pH probe. So on this screen here, we can calibrate our pH probe. So we connect it to the instrument, and then we'll hold it in different solutions. So here we have a buffer of 7 pH, and that's where we calibrate it for 0. And then we can have additional kind of sort of spans, I guess, to set that calibration curve. Data dictionary, there's a new group called Aquatic that has all the different, I guess this one only has 3 things, but there's some new features that's added with Aquatic that you can find here in the dictionary. Moving on to environments, I'm going to wake my instrument up here, so it might be a little bit loud. We'll put it in standby. Going over to environments, actually, you know what? No, we'll leave it open. So this is going to look slightly different for the aquatic chamber, especially the flow screen, as Rod mentioned. I'll turn flow on here. So we have our chamber included here, where we can see the pH in our solution. So if you actually had, I don't have one connected right now, but if you actually had a pH probe connected here and it was in a liquid suspension, you would be capturing that, the pH of the solution, assuming it was calibrated. So we can turn the pump. So this is a sub-sample pump. So if we turn this pump off, or this flow off, and then we turn the pump on, we can see how air is circulated through this headspace volume into the aquatic chamber. I'm going to turn this off for now, and then the fan automatically turns on at some set RPM. Otherwise, it's fairly similar to how it looked before. You have your sample and your reference airstreams here. H2O, no difference here, same thing. Just remember what Jason talked about when we do a set point here. We just want to make sure that we have a small delta between our reference and our sample. But you want to just control them, that's up to the user, but here it looks the same. CO2 looks the same, fan is the same. We'll go down here to temperature. You notice here we have the TAQ. So that's the aquatic temperature. And this is a thermistor that's embedded into the cuvette. And it's measuring that sort of wall liquid temperature. Here is where you can also connect another thermocouple if you want to measure ambient temperature, just to ensure that no condensation is occurring in your tubing. When we make measurements, we recommend controlling on T exchange. So you would set your T exchange the same to what your water bath would be at, just to ensure that the instrument and the water is at the same temperature. Moving down to light, the only difference really here is going to be that we have a new transmittance factor. So right now this one is just going to be 1, but it's going to be implemented here later, just to account for whatever is lost in light when we pass through that first window into the cuvette. Fluorometry and fluorometry looks the same, so there's no difference there. Just think about those parameters that Jason was talking about, how they might be a little bit different when you measure them for aquatic samples. Auxiliary, a lot of these are, so this is the DAC or the DB25 input here. So some of these are locked, we can't control them. And that's, you can see here what's being overridden here, what it is used for. So we have some orientation alert here. If the instrument notices that the chamber, the sensor head has been tilted, then the pump will automatically shut off to make sure that we're not pulling any water into the ergus. And then we have the circulation pump and the pH probe. Auto controls, it's the same. Moving into constants, our gas exchange group has changed slightly. So here, this is where you would specify your volume for your different, cell density or chlorophyll density, if that's something you want to normalize your flux to. Going down into the aquatic chamber. So this is the aquatic chamber constants. These two will disappear, fan on and pump on. We'll just leave this pump speed where you can set it between 2 and 5. 4.5 is typically the recommended set point. And if you notice any flow restrictions or anything, you can increase it. Or if you think it's too vigorously bubbling, you can decrease this voltage. Leaf light, user fluorometer, and all these are still the same. It's called leaf lights, but if this is something you want to estimate for your algae, then go ahead and enter these or change these parameters. Okay, moving on, stability, same thing. We don't notice any difference, or there's no difference here. Log files, the only thing is under constants here, what we're gonna log. So we have additional constants here, right? The cell density or the chlorophyll density or the mass. Otherwise it is the same. Matching with the aquatic chamber. Let's see here, exits H2O. We recommend, just because we're gonna see a small delta, we recommend doing point matches instead of range matching. It's been shown to be slightly more accurate, or it appears to be slightly more accurate. So we just recommend, especially since measurements take a little bit longer, just doing point matches. And I think that is it for the software. So a lot of it, just notice, a lot of it looks the same as before. There's just some additional features. But without any further ado, yeah, that was it. Thank you so much.